Today, we're diving deep into the microscopic world to see how massive, everyday things, like your floor tiles or super advanced industrial parts, are made. And it all starts in a place you'd never expect, the world of powders. You know, you've seen it before. Two tiles, they look exactly the same, but one will last a lifetime, and the other one cracks the first time you drop something on it. So what's the difference? Well, the secret isn't just about how it's baked in the kiln. It's about something that happens way before that. In the ceramics industry, these are the usual suspects. Lamination. That's where the part literally peels apart in layers. These weird S-shaped cracks that show up after pressing, or just annoying chipping on the edges. And here's the thing, these are not random accidents. Nope. They are all symptoms of a single problem that starts with the powder. And that's really the heart of it. The key to a perfect, super strong ceramic part isn't some secret in the giant press or the fiery kiln. It's hidden right there in the powder. If you get the powder wrong, you're basically designing the part to fail from the get-go. Okay, so if the powder is that important, what does the perfect powder even look like? Well, let's introduce the hero of this story, the engineered, spray-dried ceramic granule. And this really shows you the night and day difference. On the left, you've got just plain old milled powder. It's dusty, it clumps together, it just doesn't flow well. But look at the right. Those are engineered, spray-dried granules. They're like these perfect little spheres that flow like liquid. This isn't just about looks. It completely changes how the material acts in a factory. And here's what they look like up close. See? These aren't just little clumps of dust. They are carefully designed spheres, often with a little hollow cavity on the inside. That shape, that structure, it's all done on purpose for a very good reason. So why go to all this trouble to make tiny balls? It's all about consistency. Because they're spheres, they flow like tiny marbles, filling up the mold or die perfectly evenly every single time. This predictable packing gives you a higher green density, that's just the density of the part before you fire it. And a high, even green density is absolutely critical if you want to avoid those cracks and warping down the line. So, how on earth do you make millions and millions of these perfect little spheres? Well, for that, you need a special machine. Let's talk about the spray dryer. The idea behind it is actually pretty simple. First, you take a liquid mix of ceramic called a slurry. You spray that liquid through a nozzle, turning it into a super fine mist. Then, as that mist of tiny droplets falls through a giant hot chamber, the water instantly evaporates, and poof! What you're left with are perfectly formed dry granules that you collect at the bottom. And this is what the whole setup looks like. You can see the slurry gets pumped up to the top, where the atomizer creates that mist. It falls through that huge drying chamber while hot air swirls around it, and then the finished dry powder is collected. It's basically a non-stop, high-speed production line for creating perfect powder. Now let's zoom in, way in, on just one of those tiny droplets. The second it hits that hot air, the outside surface starts to dry, forming a kind of solid shell. The moisture trapped inside has to escape out through that shell, and this process is what creates that unique, hollow center we saw earlier. It's a critical moment that defines the whole structure of the granule. But here's the thing, this is not a set-it-and-forget-it kind of machine. Oh no. To get that perfect granule, you have to be a master of the controls. Think of it like a sound mixing board, but instead of faders for bass and treble, you have knobs for your powder. The very first knob you've got to get right is the slurry itself. Its rheology, which is just a fancy word for how it flows, is a huge deal. It has to be thin enough to be sprayed into a fine mist, but thick enough to form solid, dense granules. It's a real balancing act. And if you get that balance wrong, well, a slurry that's too thick will just clog up the whole machine, and one that's too thin or watery will give you weak, fluffy granules that'll just crumble in the press, and hello, defects. All right, knob number 2 is the atomizer. This is the piece of hardware that actually does the spraying. It's really the heart of the machine. Whether it's a super fast spinning disc or a high-pressure nozzle, its design has a direct impact on how big the droplets are, which in turn decides how big your final granules will be. And you can really see that control right here in the data. Just by swapping out a nozzle or changing the speed of the disc, you can totally change the size of the powder you're making. And that's essential, because different ceramic parts need different size granules to press perfectly. Okay, our last big knob on the control panel is temperature. You've got to carefully manage the temperature of the air going into the dryer and the air coming out. This delicate dance controls how fast the granules dry and lets you nail a super specific final moisture level, which is just absolutely crucial for pressing.
And yeah, getting the temperature wrong is a recipe for total disaster. If you run it too hot, you can literally cook the binders that hold the particles together. The granules become brittle, and they'll just shatter in the press instead of squishing together. And if it's too cold, you get a sticky, clumpy mess that won't flow at all.
So, you spent all this time dialing in the slurry, the atomizer, the temperature. How do you actually know you nailed it? Well, that's where quality control comes in. Let's head to the factory floor.
On a real production line, these are the powder's vital signs. Technicians are constantly pulling samples, measuring the size of the granules, checking the moisture content down to the tiniest fraction of a percent, and testing how well it flows. A lot of times, they'll even do a small test pressing in the lab just to be 100% sure the powder will behave perfectly before it goes to the main production line.
So in the end, that's what it's all about. All this incredible science, all this precise engineering, it's all laser-focused on one simple goal: to create a perfectly consistent powder so that you can make a perfectly consistent product every single time. It's such a powerful idea, isn't it? The idea that the quality of the biggest things we build often comes down to perfecting the smallest, most invisible components. You see it everywhere, from the individual transistors on a computer chip to the exact mix of sand and concrete. The whole thing only works if the tiny parts are perfect. Where else do you see this principle in action? Thanks so much for tuning in.